This is notes 1.4C.
Pick it up. That's easier.
Will we ever put in page 26, 1.3?
Maybe. Not today. I'm drowning in papers. Okay, so we're going to be talking about applying the three variable systems. And before we do that, I want to talk about different types of solutions. Before we do that, this would be something that you could put into your notebook. I would write in your notebook possible solutions for three variable systems, and then just make a note to yourself that it's on page 30 if you want to see the pictures. These pictures are a little tough to draw, so you can see these same pictures on page 30. But there are three different scenarios, and I would write down the three different scenarios. You don't have to write the description, but it is possible for a three variable solution to have exactly one solution. Okay, so I would write that down. Possible solutions, page 30, and then one of the possible solutions is exactly one solution. Okay. Now, exactly one solution is basically the types of answers that you were getting on your homework last night. So whether you solved 3 and 4 or you solved 5 and 6 and you came up with an ordered triple, when you find an ordered triple, you're finding a point in space. We talked about that we're adding a third dimension here. So this is three planes in space, sort of like a brown, a green, and a blue. And the three planes intersect, and all three intersect at a single point, sort of like that corner point on the inside. Okay? And that's what it looks like when they have one solution. When we did two variable systems, we just had two lines in two dimensions. And so when two lines crossed to form some kind of X, they had 1 point solution, right? And that's when you got an ordered pair. We also, back in Algebra 1, had the case of infinitely many solutions. And that's when you would have, in two dimensions, a line that was on top of the same line. And so they shared all the points in common. For infinitely many solutions, you're going to have your three planes, and instead of intersecting at a single point, they're going to intersect along a line. Or, oh, there's a picture missing. Oh, it doesn't have a picture. So they could intersect like they are here, sort of like fanned out, and see this black line right here? They're intersecting all on that line, so that's infinitely many solutions. Or, we don't have a picture for this, but you could have a plane on top of a plane on top of a plane, and then they share all those points as well. So that could be another infinitely many solutions. Now, I don't think you had any infinitely many solution problems on your homework last night, but can anybody think back to Algebra 1? What happened? It's sort of weird when you're solving a system in two variables and you come up with infinitely many solutions. Like, when did you answer that? Does anybody remember what sort of weird thing was happening in the solving? Lilith?
Wasn't it when they turned out to be equal or something along the lines of that?
Yeah, so you might do elimination, or maybe you're doing substitution, and whatever you do for elimination or substitution causes all of your variables to disappear. So like in the two variable system, the x is gone, the y is gone, there's no more variable, and then the two sides of your equation are equal to each other. So I'm going to put, under your infinitely many solution, I would write this down in your notebook, 0 equals 0. Now, technically it doesn't have to be 0 equals 0. It could be any number equal to itself, 5 equals 5, 1 equals 1, as long as the statement is true. So if you come out with no variables, all your variables canceled. So you can't solve for x, you can't solve for y, you can't solve for z. And the statement at the end is true, then you have infinitely many solutions. And what's true if it's no solution? When there's no variables, so all your variables cancel out. It's really weird because you're like, what do I solve for now? Nothing. Your you're just looking at the numbers, no solution is 0 equals, I'm going to say 1 here. That's a common thing that happens. So let's say 0 equals 1. It can be anything that's not true. So I'm also going to write here any false statement. Okay, so it could be 0 equals 5, it could be 2 equals 3. We would disagree with those. Okay. So on tonight's homework and on your quiz on Friday, you might encounter some of these scenarios. Just be prepared for that so you know what to answer if all your variables are canceling out. It's actually kind of nice in the 3-variable system when you get those, and in the 2-variable system because then you don't have any more solving to do. You just stop and say your answer. Okay, so kind of be aware of that. The same thing can happen in 3 variables. Any questions about those possible solutions that you want to address? Okay. So we're going to get on to the applications of 3-variable systems, and a lot of times when math teachers, especially in high school math, we say the word application, what sorts of problems do you get to do? Word problems. Okay. And sometimes the word problems feel like a little bit contrived, right? I get that. I'm with you. I understand. But the idea here is that we need to learn the basics of how a system works and what we could do as solutions of the system. In the real world, systems of different types of equations can actually be really useful. There's like a whole category of mathematics called operations research, and you're writing systems, but they're really big and they have lots of variables, and they're too big for a human to take the time to solve. So then you're also using programming, and you're programming a computer to solve that system for you, and you can answer different things. So that's kind of a cool use for it. We're not at that level yet. We just want to know the basics of how a system can work, how we can write these equations with different variables and then get a solution. Okay? So here's our first problem. Now today in our notes, I'm going to focus on writing the equations, the setup part. And we're not really going to go through and solve them all like we did yesterday because I want to give you time to actually work on actual homework problems. And then I want to be able to go around and check the minor errors you might have in lessons homework. So I think it would be good to jot something down in your notebook. You maybe don't have to write this down word for word, but get a gist of what's happening in this scenario. We have an amphitheater. It's charging $75 for a seat in section A. It charges $55 for a seat in section B. And we're charging $30 for a seat on the lawn. There are 3 times as many seats in section B as there are in section A. And the revenue from selling all 23,000 seats is $870,000. And the big question is how many seats are in each section at the amphitheater. So as some people are still writing, but some of us are kind of finishing up, one of the things that you're going to want to do when you're writing these 3-variable systems, and I really highly encourage this, is take 30 seconds to 1 minute to decide what am I even being asked to find, and then decide on the variables that you'll use and what they'll actually represent. Because if you decide on the variable and what it means, it makes it a lot easier to write the equations that you need. So as we're kind of surveying this problem, what are we being asked to find? How how many seats are in each section. So that would be how many seats in section A, how many seats in section B, how many seats in section C. So those should be our three unknowns. And since they're using section A, B, and C, we might use variables A, B, and C. Okay. So A, and I'm going to write this off to the side. A will represent the number of seats in section A. B will be the number of seats in section B. My quotes just mean copy and paste. And C equals the number of seats in section B. I mean C. Oh yeah, the lawn section. It's not called section C. Oh, you're right, the lawn. Thanks. Alright. Okay, so what I want you to do next is reread, and if you want to discuss with your group, you can, or toss ideas out, or check things. What are the equations that you can write based on the information provided in the scenario? And if it's a 3-variable system, you're going to have how many equations? 3. Okay, so see if your group can come up with 3 equations for you.
So I'm just gonna go.
No, you don't need to solve it. You do not need to solve this system. We're just going to practice writing the equations. So can you write the 3 equations with your group?
So you're trying to find the actually equal to if you do say yes, so okay.
Just writing up the
Oh, I thought you were.
Okay. So I see
No, this is for your power.
Yeah.
Stack of what other?
3A does equal B.
Just pick one.
What's
Do you know?
or 3B equals A?
The price of the seat. And what is when people buy the seat?
Alright,
So we're gonna have to control that.
That first one. Second one, 3. And that was oh, you're right. Plus 3B plus C. Yeah.
Oh,
Put all the money in an equation together. Yeah. Write it down.
Wait, wait, okay. Actually, this is order. So, can I see your equation? So, how many equations do you guys have? What's this?
I'm gonna do A plus B plus C.
How it's
So I think you have 2 equations that are really like the same equation.
I have that for the report too.
And which one is the right equation? So A plus B plus C
What's the
equals
last
23,000. I would keep that one. You've got an idea there, and it has to do with that sentence. But that's like a brand new equation. It doesn't necessarily have to do it. You have to go with 23,000. It could, but then you need to edit it. But I would just write an equation for just that sentence.
Oh, wait, oh. On the SB.
Wait.
Yeah, that could be an equation. That could be one of your equations. It doesn't have to have all 3 letters in it. Yeah.
Just said that these three divide by.
Yeah, what were you saying, Bo? You basically- What does 23,000 represent? Because all of these, right? So how do you show all of these?
And then be like, okay, these just three names.
Anything that.
Out of all the seats in A, with all the seats in B, with all the seats in A.
Like the way the.
See, I think that might be a problem because, three A equals B, there's a lot
And then
of
because
these very.
these three are what make it C. And then this was.
Yeah, you got two equations, like.
It's hard.
Okay, let's come together.
Is that right? Hey, what are these?
Okay, now, a lot of times when a math teacher assigns a word problem, the students come back to class the next day and then that problem doesn't have any kind of work. Why is that? No, it doesn't have any kind of work. It doesn't, it's like blank. Because you saw words and you were like, nope, can't do it, right?
Yeah.
So you gotta get over that hump. We gotta be able to write systems on our own. And so we have to kind of like look in the problem and try to figure out important information. So in addition to the prices for the seats, I'm getting other information about the amphitheater, right? And then I'm gonna use those other bits of information to try to help to write equations. But one of the first equations that almost every group wrote was the equation about money. So you guys did an awesome job. If we know the price of every seat, and we know how much money the amphitheater is taking in, put all of those things in a single equation. So one equation should be 75A plus 55B plus 30C, which means if I have 10 lawn seats, I make $300. Charlie, stop it. If I have 100 lawn seats, I have $3,000. Okay. If I have 1,000 lawn seats, I have $30,000. Okay. That total has to equal 870,000. Sorry about that. So that was a good one, right? Put all the money in the same. The second most common equation as I was walking around dealt with the other bit of information here. The revenues total is 870,000, and then people caught on to this 23,000. So 23,000 represents all the seats in the amphitheater. And how would you count up all of the seats? A plus B plus C or A plus B plus L, whatever variables you used. A plus B plus C must equal 23,000. Okay. Now, the last and probably the most challenging equation to write correctly is the one for this statement right here. There are 3 times as many seats in section B as there are in section A. And as I move around the room, I see 2 equations. Okay, so hang on. I see 3B equals A, and I see 3A equals B. Aiden, were you going to give me one of those?
Yeah, I was gonna say 3B equals A.
3B equals A. And what's your reasoning?
Like, you see, there's 3 times as many seats as section B is
So does your equation do that for you? Why? Yeah, there's more seats in B, right, than there are in A. So this is weird because it says 3 times as many in B, so you just want to write 3B. I get it. But you have to stop and be thoughtful because if you write it 3B equals A, that's the wrong equation. Okay? It should be 3A equals B or B equals 3A. So if you're like me and you have trouble, like which direction do I write that? 3B equals A, 3A equals B. I often like just plug in numbers and see if it does what I think it will do. So like, what if B had 10 seats? In this top equation that I crossed out, then 3 times 10 would equal 30, and A would have more seats than B. Is that what I want? I want B to have more seats. So then I try it. What if A had 10 seats, then B would have 30, which is 3 times as many as A. That's what I'm looking for. So if you ever get to one of those equations and it's a little bit tough to figure out what to do, go ahead and just plug some numbers in and see if it's actually giving you what you think it should. After this, so you've got 3 equations, and that's all. We're just practicing this in our notes today, writing the 3 equations. I'm not going to solve it. But this third equation is really nice because I know that B is equal to 3A. I can sub 3A in for B in the other 2 equations. And then I'll be able to combine like terms for the A's. And then I'll have 2 equations in terms of A and C. And then I'll solve my regular 2 variable system. So I can keep solving. We're not going to solve it in interest of time. Okay. I've got one more that I want you to read and write equations for. So we're at a swim meet. Papillion La Vista dominated in the individual events. 24 swimmers placing in their events, scoring a total of 56 points. A first place finish gets 5 points. Second place gets 3. And third place gets 1. This is all made up, so I don't know if that's true. Having as many third place finishers as first and second place combined really shows the team's depth. And the question is, how many swimmers finished in each place? Take your eyelash, pull it away from your eye, and then look up while doing that. What are we trying to find? Number of swimmers that finish in each place. What letters do you guys want to use?
ABC.
Could do ABC? Could do
JKL.
I like FST, first, second, third. That way when I see an equation I can keep track of what's what. Could you use X, Y, and Z? Yeah, you can use anything you want, right? So FSL, I'll use capitals. Or FST, sorry. Okay. Number of first place. Number of second. And number of third. Okay. So what's an equation we can write? Liam?
5F plus 3S plus T equals 56.
Yeah, just like we had that equation full of money, now we have an equation full of points. So it's like information that groups together should go in the same equation, right? All the points should be in the same equation. Don't put points in any equation, not about points. What else do we know? Lilith? F plus S equals T. And you're addressing that statement in the middle. Having as many third place finishers as first and second combined. So if someone said, like, how many first and second place finishers did we have combined total? We just add those up, right? F plus S. And that's equal to our third place finishers. What is our third equation going to be? TJ? Add them up. The first place plus the second place plus the third place equals 24 swimmers. Okay. So it's usually not so bad setting up your own equations. Again, a couple things that can help you. Number 1, choose your variables in the beginning so that if you know what your variables mean, it makes it easier to write an equation. Second thing, if you have one of those weird ones like the section B and section A, and you're not sure if your equation actually works, Just plug some numbers in on the side and see if it does what you think it will do. Okay, your homework assignment is on page 34. 12, 14, 17, and 23, 24, 34.